Okay, and you can hear me?
So far, so good. Go ahead.
Okay, I'll keep my video off, but hi, everybody. Thanks for having me. I am here to talk to you about our project at the Smithsonian Institution, testing OpenAI's Whisper to make captions for audio recordings, and I'll give you a little background. I am Crystal. I work at the Smithsonian Institution. I am a white woman in a green shirt right now in my house, a mile from the Capitol in Washington, D.C. This is a picture from a Dr. Seuss book that is adorable. Next. Okay, yeah, that's me. I was hiking the Teton Crest Trail and then I broke my ankle, not hiking the trail, but at a music festival. So I'm very sorry not to be there. I had planned to come, so I appreciate remote participation in all forms. So thank you very much. I work on a digital asset management system where we have 35 million files to take care of, about 200,000 of which are AV files. So a smaller collection, still large. And part of my role is to advocate for and work to build tools to take care of these files and to make them accessible. So this is how this project started, as sometimes they do. My office mate, Mike Trisna, is a data scientist in our research computing lab. And he sits next to me, and in 2023, I was like, hey, remember when everyone was using ChatGPT all of a sudden? Maybe we could try out some of these tools to make captions for our audio files. And so we embarked on this project. I'm an AV archivist, he's a data scientist, so we kind of pooled our resources and really thought about a machine learning project and the fact that it is iterative and it involves all these steps. I really like this slide that highlights this sort of process that we went through. And this is not just my project, it is many, many people at the Smithsonian. This super group has been meeting monthly for a year to do this work on top of their jobs. So people from the Folklife Center and Archives of American Art and Smithsonian Libraries, in addition to our Transcription Center and our Access Smithsonian Office and digital platforms. So, of course, as a federal agency, we are mandated to apply with accessibility requirements. We had 17,000 public audio recordings at that time, and I asked for $1 million to make captions for them from vendors, which is what we were doing. And I got laughed at, but it really set the scope of this. Our goal was to see if we could make publishable captions for this pile of files that were already public. Of course, making captions and transcripts also makes them more findable. This is the curb effect. And it is a very good thing to do, and it is good to do it well. I learned a lot about inclusive design. Oops, I'm sorry. And of course, we don't just have published clean recordings. We have variable recordings that I'm sure a lot of you encounter, from transfers, things that can have multiple speakers and multiple languages, and lots of noise, lots of variables that we wanted to test. So this is really where we put a lot of our effort and a lot of our advocacy, that this is, we could test with a set of files that are clean and, I keep saying clean, but are published recordings, high production recordings, which we did, but we also really needed to test with other type of variables. Here's an example.
Talk the Quechua. Quechua is a native language from Peru.
Oh, you can speak Quechua.
I can speak Quechua.
Now, we have to hear you say something in Quechua here.
Sure. And I say, Imainaya Kachkangi. Repeat with me. Imainaya.
But wait, what are you?
So just an example of different types of recordings, and we built a media player last year, which we called MADS. It's based on the open source Able player that comes out of Washington State University. I'm happy to talk to anybody about this if they want. But basically, we input VTT captions and audio descriptions to the player in this workflow that we can scale up inside the Smithsonian. So we're really looking for VTT files. Here is an example of that player in action. I didn't give you the sound, but you could go to Institutionally Dead website and listen to Jerry Garcia talking. This is an audio file with captions in the player with a time transcript. So, of course, VTT is time to text with timestamps. So what Whisper does is it takes the audio and makes text and turns it into these VTT files that we can play along with the audio or video files. We looked at some tools, and of course we chose Whisper. It's the open source automated speech recognition tool. Released 5 sizes of model weights. This just means like different sizes mean different compute power requirements, different time, and different outputs. So we did choose the largest size because we were able to use our high performance cluster, usually available to scientists in our data center through the research computing lab, and we wanted to test the largest model weight. And of course, we came up with a set of metrics. If anybody wants this, it's a Word document, or how to score the AI, score Whisper, both quantitative and qualitative tests that we did. Are the timestamps and spacing accurate? Does it stop in the middle of a sentence? Does it do speaker identification? Of course, are the words accurate? Does it output nonverbal captions like applause? We looked at these variables and noise, accents, crosstalk, multiple languages in a recording, and musical performances.
Mention those over 40. Why is that? Is it?
This is an example where in the very beginning we compared Whisper against our Smithsonian Transcription Center volunteers making captions and vendor output. And it's pretty illuminating to look at differences in style, not just words, of course, word accuracy rates, but in style. And so I just play a little bit of this for you. This is Smithsonian Archives recording about polio vaccine, which is also relevant.
Mention those over 40. Why is that? Are they less susceptible?
98% of paralysis occurs in people 40 and under years of age. And for public health reasons, one has to cut off. And the cutoff has been at 40.
So just to show you, there's lots of different ways to do this work. And inclusive design is also an important component. So some findings here. Our sample set was quite small, and we only, just because we're all stretched, but we had 80 recordings of high quality production level, and we did about 15 recordings of different variables. So we're still very much testing this out, but we saw some very consistent themes across them. Whisper performed very well in the speech to text being really accurate. Word accuracy rate is very high. Especially with those standard production recordings, but also with speakers talking over each other with some minimal crosstalk. The presence of external noise, it performed very well, output accurately. Speakers with accents, it was able to also be quite accurate. And so we have a lot of high scientific terms in our educational recordings, and it got them really accurate most of the time. I had to look up a bunch of them and check spellings and things like that. So we were pretty impressed with that. The spacing and the amount of text on screen was really good. You could set in Whisper how many lines you wanted to output. So we stayed inside the 2 to 3 line standard, and it did not stop or break in between sentences, so kept full sentences on screen most of the time. And our world language recordings are sometimes called non-English recordings, are output in the language that's spoken without translating. Whisper does allow you to choose if you want to translate or not translate. I think it does 10 languages. So at this time we only tested Spanish, but so we need to expand that, but it output in the language spoken. This is the larger list of those for output. Did not perform optimally. There are no speaker tags. You saw in that example, speaker 1, speaker 2. We set the recordings through a separate tool for diarization afterwards, which we would have to do. Speaker tags are very important for us. It is difficult, of course, for the tool to output the actual speaker names, but we think that that could be useful for us to fix later if we had speaker 1 or 2. Identifying speaker.
Crystal, we missed maybe the last 10 seconds of what you were saying. Yeah, after talking about speaker tags. I wonder if she's still here. Hey, Crystal, we don't hear you at all right now.
Am I still here?
Oh yeah, we hear you now. I just got to get you up on camera, but you can start talking. I think you left off on some details about speaker tags.
Yeah, and I put the slides in the link too, and good thing I put all the text on the slides. Let me put the slide up again and see if I can keep going. If that happens again.
Okay, your slides are on screen again. Feel free to continue.
Yay. Okay, speaker tags, tricky. We had to set it through a separate tool to diarize the output and get speaker 1, speaker 2 tags, which we could add in actual names later, but it wasn't even very consistent. Musical recordings not identified with musical notes, and for some reason, lyrics don't have any punctuation very consistently. Content that switches from one language to another in the recording does translate, so it does not output in the language spoken. So if you started in one language, it would continue output in that language. Hallucinations, which is the thing people like to talk about, exist a lot, actually. A lot of repetitive text, often in quiet spaces. And then if you have a recording, which we have a lot of with empty space, no sound at the end, when you're transferring a whole recording, it makes things up. It likes to help. It wants to help fill in the empty sound spaces. But they do output as 0 timestamps in the VTT, so we think we could identify them really, really quickly in a kind of more efficient processing workflow. The external sounds, the recordings like crowd noises or applause, which should be in brackets, are not, and not often output. And then it removes disfluencies when I'm saying and ah a lot. It removes those, and we don't always want to do that for research purposes. So a lot of did not perform optimally conditions that we discovered. Of course, the Smithsonian and the community very clear about talking about a loop and a workflow that includes curation and approvals and review by humans, which is a lot of work. So trying to think of ways in which we can optimize and make that efficient. So we did learn after this process, these are not publishable results that are okay for our curators and our archivists. So we would need significant staff time to review and approve, and tools to do that, and they do not yet exist. We did look at some tools. The American Archive of Public Broadcasting has this tool called Fix-It, and it's very cool. You should go look at it, but it's not going to work for us. It's built on Ruby, and it just wouldn't be sustainable for us. But we learned a lot about it. We have a transcription center that does sound with volunteers. It's called TC Sound. You can also go transcription center, some audio recordings. And but it uses volunteers to add timestamps and type in, and then do levels of review and approvals. It could be a really cool platform for us to use internally for our staff. We did build on the left side here. We built this kind of mock-up of what we'd like to see, where the error counts are, output from Whisper, so you could go to certain places and fix the text and output new VTTs. So some of the things that we've learned about where the errors might lie could help us build a tool. We're revising our goals. We could use the Whisper output to just make our content more searchable, even internally, instead of publishable captions. We have a lot of PDF transcripts that need to be turned into VTTs, and we could use this process of already approved PDF transcription content. And then we're digging into the Whisper output's confidence ratings per word, and we're trying to test it to see if the confidence ratings are trustable. Can we trust them? To then use that to go find places in the recording to fix. This is an example. Whisper outputs a JSON and a VTT, which we turned into this CSV. And you can see this probability, the D column, I just faceted by anything under 50% confidence rating. The right side is hallucinations, It's 25% accuracy rating. So I think if we could build thresholds for what we could trust and then go to those places to fix things, that would really help us out, that we're thinking about doing. Oh, 2 minutes, okay. Communities that we're tapping into, I just built this slide, I need more on it. So if anybody knows of work being done, or anybody wants to share their work with us, that would be awesome. So I know some of these things happening. Amia had some presentations. There's this AI and oral history symposium that happened. They had a roundtable on this, and the AI for LAM group. That is all I have. Thanks for having me. Did it work?
Yeah, we heard you pretty well, except for that one interruption. But yay, and you're back on camera, on screen.
We have time for maybe 1 or 2 quick questions, if anybody has them, or comments, feedback. Sorry, I didn't see you. Hi, Crystal. I just wanted to share that I think it was 4 years ago, maybe, the EBU started up a benchmarking project that's open source for speech-to-text recognition. And they have a GitHub, they have some published markers that they're, working with, and they differed a little bit from yours. And I'm not sure if it's been very active, because it started, I think, 21 or 22. And then I just wanted to ask if you're aware of, are there any working arrangements with Whisper to give them new data sets of knowledge of languages that they don't have currently represented in their list of languages. Because I work for an organization, we have a lot of really high quality broadcast recordings, but there's basically no speech to text recognition for many of them, like Dari, Pashto, Uzbek, Kyrgyz, etc. So we have a lot of underrepresented languages, and we're interested in doing something with Whisper, but just don't know what the possibilities are. Thanks.
Yeah, that's great. The first comment was EBU group. Yeah. Is that right? Okay, I'll look that up. That's great. Thank you for that. And yeah, I don't know. I just read the Whisper news. I don't really have a relationship with them, but that's a really good comment about, I mean, I learned that I can't remember the 10 languages, but they've published them, that they trained their recordings on. I forgot, but that's, as they grow, you know, I think it's a 2022 they came out with this product, so it's still pretty new in terms of tech world. So as they grow, we'll keep an eye on that and see. That would be great for our community.
I'm tempted to allow for one more question, maybe.
Just a quick one. So Whisper is basically a Facebook product. It runs on your machine, but do you know if there's any telemetry that's sent to Facebook? And if so, what's the privacy cost of what you're injecting in Whisper?
That is a great question. We have some rules around what tech we can use at the Smithsonian, being quasi-government, and we have to use tools that are able to be run on-prem right now. So and that are, I mean, they say open source, but they haven't revealed their data sets entirely. So what does that mean? So Whisper is an OpenAI tool. They're not connected with Facebook directly that I know of. I'm sure they use, I think they came out, they use Facebook data, right, in their data sets. But we are able to run it without sending our data to them. So you can actually build your own instance on-prem and run it without sharing your data. So that was why we also decided to use it. So that's what we did. There's the availability to not feed your data into the data set. Even though I also think there's a wonderful discussion here about cultural heritage models, fed models, where we could all put our data into a model and output a data set for cultural heritage communities.
Maybe a topic for next year's
Yeah.
No Time to Wait conference. Thanks so much, Crystal. This was really fascinating.
Thank you all so much.
Oh, yes. Hello.